Hi everyone, and welcome to our webinar on our new coding resources that we've been putting together over a period of time. We've got Jason Vearing with us today, and he'll join us in a little while. Just like to welcome everyone to our webinar, and if you can see where we're from, we've got people in Queensland, Darwin area, Hobart, even New Zealand. So welcome to everyone. The lesson today, or what we're going to do today, is to go through some of the lessons we've put together. You might have remembered we had a previous webinar with Jason on programming and how to transition from text to general purpose programming. Taking that little bit step further, what we're going to do today is look at the resources we've put together with lesson plans, and Jason's done a whole lot of work on some video tutorials, and that's what we're going to do, is talk you through today with that video tutorials and the lesson plans that Nathan Allison has put together for us. So it's been a really great effort, and we're hopefully today you'll get a lot out of this webinar to take you through those resources and how you might use them. So who are the resources for? You might be looking to improve your own skills on the fundamental skills on programming, and we've got JavaScript and Python that we're looking at. You might also have a need for your students to look at some structured programming, so it's building on their confidence and their skills as you develop them through. They might be transitioning from a visual programming language to a text-based language like JavaScript or Python. But also you might have you might be a primary school teacher and you want to do some further work with, say, Scratch as a visual program, and to get into that, really the fundamental programs that students may not get if they just do it through exploration. So the structure of our lessons, what we've got, the way they're developed, we sort of set up a scenario where we look at a task and we decompose that problem. So the important thing in part of programming would be in terms of constructing the computational thinking, or deconstructing the problem and using computational thinking. And you might do that through a flow chart or through using pseudocode. Now, if you're not sure what pseudocode is, we're going to go through that today, so fine. It's also in the lessons, it talks a bit more about that. Then you might get the students to build a program, whatever it might be, and we've chosen some fairly simple applications, so we're really targeting some success for students, but also we're going to then take on the task of tinkering later and modifying that program. But to build a program, what we're doing is providing some video tutorials, which you can use with your students as a class. They can use it as self-paced learning, or you can use it yourself as a prelim before you actually run the class. So there's a lot of ways you can use it. And as you're doing the webinar today, maybe think about how you might use these resources with your students. There's also, we provide some solution code to trace the errors, to compare what students have done to one of the functional codes that's working. And it might even be, if you've got students who aren't that capable in terms of programming, they've got a starting point to use one and then modify that code. The Tinker task will make small modifications. We'll go through that, and you can remix a particular part of the program. And then there's a challenge which allows you to go a bit further, to write their own programs and modify the programs using the skills that have developed through this sort of each of the lessons. So that gives you an idea. You can sort of also differentiate. If you've got students who are really speeding through, you've got some activities there you can use for those students who might go ahead. And we're always there's in our classrooms is students of varying abilities. So that's basically what we want to get to today. On the bottom there of the screen, you can see a link to it's called PRIM, a structured approach to teaching program. If you wanted to look at the blog for that, you can download the handout in the you can use the handout. So in our handout we've got today is I'm just going to go through that link. So the handout is on your dashboard there. It's called handout 1 index page, and if you click on that, it'll go to the index page. So I'm just going through there now, and this index page has got the course as it is, the setup, the basics, and then lesson 1, 2, and so on. So I'll just go into lesson 1 just to show you very quickly how it looks. You've got curriculum links, so you can have a look at the curriculum links. And you've got an assessment as well. Each one has sort of a learning input, and you've got might have a flow chart. If you didn't understand about pseudocode, there's a pop-up there that explains pseudocode. Each one has a video, as I mentioned, and some solution code. So that's Jason going through a tutorial, and then how to modify the program. There's the challenges. So I think it's a worthwhile resource that you can go through. There's 5 lessons at the moment, and Jason's done a lot of work in putting it all together, so thanks, Jason. And I might throw over to Jason now. He can take you through the next part of the webinar.
Hi, Martin. Okay.
Yep, it's just should be coming.
So, yeah, thanks for having me along, Martin. Very excited to share what we've been working on. So Martin just quickly went over lesson 1, and what I'm going to do is just show you some outcomes of how these are going to look when they're fully finished. So the first application that's going to be made is a Celsius to Fahrenheit converter. You type in Celsius, and it outputs the equivalent in Fahrenheit. So this one here is in Python using tkinter to make your graphical user interface. And in JavaScript, which is a web-based program, it's essentially the same thing. Click on the button, enter your degrees in Celsius, and it outputs in Fahrenheit. So of course, you have to crawl and walk before you can run. So in this series that we're doing now, we're not doing graphical user interfaces. We're just going to be using text-based versions. But we just wanted to give you some inspiration on what's coming next and what we're working towards. So in the videos, as Martin said before, we've got some here on setting up. And how we set up for this is that we've got 3 web screens. One goes from scratch, one does Python, and one does JavaScript. And they're all web-based environments. So this just takes out that technology issue when you're first starting. Is trying to teach Python properly with the command line and the terminal can be a nightmare. So we say use web-based environments to start with. And then once you're used to seeing the output, then students are a bit more determined to overcome those initial hurdles. So that's what that first video is about. The second video is just a couple of gotchas, particularly with the JavaScript environment that we use. I use JS Fiddle, and there's a bit of an issue with how we output data in Microsoft Edge doesn't output in the way that I've shown. So if you have to use Microsoft Edge, in that video, I just cover some alternatives to get the output. But hopefully you can use Chrome or something else. And then before we start lesson 1, which we just touched on, we've got some basics, and this stuff is crucial. So I'm just going to spend a little bit of time talking about the content that's in these 3 videos here: concatenation, variables, and this weather application that we make. Because all the applications, they all follow the same process. I've got a sentence here that says, learn how to store, concatenate, and output data. And essentially, all of the programs do that. So we really need to get that foundation strong. So I'm just going to go over a couple of basics of coding that we just have to cover. So when we print, we have our output. Our first output would just be hello world, and that's just a string of text. So that's fine to do that. But then we want to get this idea of concatenating, which is getting two bits of data together and then having that as your output. So instead of having one sentence, hello world, we'll get hello and world, and we'll concatenate that into the output. And you've just got to make sure you've got your spacing right. So that's just what that first video is about, just the very basics of concatenating. And concatenating is in just about every application that we make here. Then the next video is about variables. And variables are all over programming. And essentially, a variable is just a container to store your data. And a really great way to think about it is if you think of your phone directory, you get someone's name, Michael, and you put their number under Michael in the list, and you've got these 10 digits associated with that person. Anytime you want to get that data, you don't care about the data. You don't have to remember or know what that number is. You just got to go Michael. And so you look through the list, find Michael. And that's how variables work in programming. They're stored in a logical place that the computer can easily find it, and all it cares about is getting that bucket. So if Michael changes his number, that data that's inside the bucket, you don't care. You just go to that same spot and find Michael. And that's essentially how variables work. So there's a few exercises in there about how we just sort of build up so that when we're concatenating like before, instead of just concatenating two words, now we want to throw a variable in there and concatenate that. So instead of hello world, we might have this variable. Let's say this was the variable, and we would have the first time it says world inside there, and we say hello world. Then we change that to, from this bucket is called place, we might change it then to Australia. So then we say hello Australia. Or then we might change the value inside this bucket to Brisbane, and we'll go hello Brisbane. So we just get used to concatenating with variables now. And then the last step is putting that all into practice by making a very simple weather application. And when I say that, it's just the sentence that says the temperature today is 24 degrees. So we just output that first of all, and then we break it down into the temperature today is, then 24 degrees. And so we're concatenating words with this variable to get our output. Now, one of the big problems that we have, particularly in Python, is the output when we're concatenating, is where when we're concatenating data or words with numbers, it just doesn't like it. So we talk a lot in that video about just some good practice ways to get that output. And a lot of the time you have to convert the number into a string format so that you can get that tangible output. So once you get through those basics, well, then we look at temperature converter. And this is the one we just showed you before. So I'm just going to now show you the text-only version of that. So while I showed you those fancy graphical interfaces, when we're working to start with, we're just going to have text. So we'll make it in Scratch first, then Python, and then JavaScript. So let's have a look at Scratch. Run our program. Let's say enter 35, and it outputs 95. So this is stage one, where it doesn't really say 95 degrees Fahrenheit or anything like that. And then if we look in Python, we run the program, enter 35, and we get the output of Fahrenheit. So I could talk a little bit now about how this code works. So there's 4 steps. Get the user input, convert that user input into a number format so that that number can go through this calculation. So that user input here is stored in that variable. That variable is turned into a number, and then that number, let's say it's 35, is multiplied by 9 divided by 5 plus 32. And then that answer, which we know is 95, is stored in this variable, and then we output that variable. So you can see it's only 4 lines of code. The only tricky part is just where you convert that user input into an integer, because if you don't, I'll just show you if we run without that step, it looks okay to start with. And then we get this message and it says, unsupported operands for string and integer. So we have to do that conversion part in Python.
Jason, can I just make a point there? Can you just go back to that screen? Is it possible to go back to that screen you just had?
Absolutely.
Just to make the point there, we've got the hashtag and then the gray comments. So that's basically I think you generated the pseudocode or just some comments first. So that really got you thinking going in terms of how to write the program, the next part of the program in the programming language. Can you just mention how you do that? What's the thinking behind that?
So, okay. Of course, it freezes up on me. But generally, we would write out the 4 lines that are gray there. So getting the user input, converting that input into a number, run it through the formula, and then output. And the hashtag goes in front of it, and then that makes it so that humans can see it, but the computer can't read it. And commenting code happens all across all languages, so it's a very good practice to get into early on. So in our JavaScript version, same thing, you'll notice we've got get user input, convert the user input into a number, run that number through a formula to get Fahrenheit, and then we have output or concatenation later on. So if I run this, my user input in this case is going to be 30. That 30 is stored in this variable here called answer. I convert it to a number, so now 30 times 9 divided by 5 plus 32 is 86. That's kept in here, and then we just output or print the value of that variable. So that's stage 1, is just getting an answer from user input, and you watch how your data goes through the program. The second step is let's make our output a bit more user-friendly. So again, we will look at this in Scratch, Python, and JavaScript. And it's exactly the same. We get our user input, 30. When we run this, the output is much friendlier. It says you entered 30 degrees Celsius, which is, memory shot, which is 86 degrees Fahrenheit. Well, looks like that one didn't work. Then in Python, it looks like more code, but it's essentially the same 4 steps. Get user input, convert it to an integer, put it through the formula, but this time we have to convert it back into a string so that it will concatenate. And this is really the key learning of that weather application earlier on. You'll see here, we've got red and green. So red is the data type of string, which is really words, and numbers are a different data type, and it doesn't like to combine them without converting them. So when we can see our output, you entered the value of variable 1, degrees Celsius, which is the value of variable 2. It wants it to be in a string format to do the output. So let's just see if that works. So if I enter in 35, it says you entered 35 degrees Celsius, which is 95 degrees Fahrenheit. So that's this part here. Now, if I didn't convert it back into a string, so at the moment, the Celsius is still green number, and that would go into here. The red and the green will get an error message when we get to that part of the program. So the first part of the program is fine, and then it says, must be a string and not an integer. And this is just really crucial knowledge to have before you start building a big program. If you can get a good handle on it on these small programs, it will save you heartache later on. So I do go on a lot about this throughout the videos, and you just need to really have a handle on it.
I was going to say the beauty, I think, of what we've got is in the tutorials when you go through them, that very clear and it's step by step, and you go through all those bits and pieces. So like in the webinar today, we're not really going to teach you how to do programming because Jason's got all those videos there. So we're just trying to go through some of the parts of the lessons just to give you a bit of a sense of what's there. But you know, the videos that Jason's done are really detailed tutorials, and it's also, you'll see there when he's talking about say in that section where he's put the concatenation, that we're sort of doing some modifications where students can making their own changes to the program. So yeah, just be aware that the videos there really go through in that in detail, and you know, we're probably not going to go through that on the webinar tonight.
Yeah. My goal with the videos was just to appeal to the lowest common denominator, help the people that really want to get the basics down.
Can I just ask you, sorry, Jason, just in the Scratch one, because I know we've probably got a lot of primary teachers watching, and they're probably, one thing to realise is that if you go into See Inside, which Jason's just going to do now, it shows you what the actual blocks are. So those blocks, Jason showed you how to in the Python and the JavaScript, but that's how the setting up is done in the blocks program. And throughout each of the videos, Jason goes through and talks about how to do it first in Scratch. So if you are a primary teacher and you're looking at it and thinking, oh, you know, I don't really know how to do Scratch, but I might just build some of these applications with my students, that's you might use the resources for that purpose. So we can use for year 7 and 8 the JavaScript and Python, because that's the general acceptance there in terms of that year level is to go into general purpose programming. But for year 5, 6, we're really all thinking about is visual programming. So you can use this resource as a primary teacher, and it steps through how to use these applications. And it brings in things like operators and things that students may not, you know, if you're there just exploring animations and so on, they're probably not going to go into this sort of detail. Would I be right there, Jason?
Yeah, absolutely. And the way of starting with Scratch and then making in Python and JavaScript is a great way to make sure that you've got the data, you've got the logic layout, you've got that correct. If you can get it working in Scratch, you should be able to get it working in Python. And if you're having a problem, it's probably more of a typo than the actual layout if you follow the same layout. So I'll just now go through a couple more of the lessons that we've got. You get the gist of those ones. So after you make the temperature converter, take that knowledge and make a currency converter. So in that video, I going into Google, just getting Australian to US dollars, making a currency converter, but you could choose any currency from that drop-down list there. And it's sort of planting the seed that later on, you could actually import data into your application and have a drop-down of currencies and so forth. Then we have 2 more bonus videos. These aren't really teaching you, but what they do is I've just made these in Scratch, and they're just more advanced applications of the same idea. So the Bitcoin tracker is really about my regret of not buying Bitcoin when it was 8 cents, and my friend told me about it in 2010 and how much money I would have if I had bought it. And the second one here is my kids watch a lot of Netflix, and there's one show in particular, and I did a program to show them if they've watched this season and they've watched it several times, how many days have they actually spent equivalent in watching that Netflix show. So it just gives you some ideas that once you get one concept, you can branch out into others. And then the second lesson is a calculator. And it's not a full-blown calculator. This is just teaching branching. So you put in 2 numbers, and then you make the choice, do I want to add those numbers, subtract, divide, or multiply? And the choice presents itself. Whatever you choose, A, S, D, or M, will affect the 2 numbers. And then at the end here is another bonus video. This is I knew that would happen. International Space Station position. Can you take Roxy outside, please? So International Space Station, this is really quite cool. So I'll see if I've got it here in Python. So what it is, no, we haven't got it on here. But basically there's a web page that has live data of the International Space Station coordinates. And you can hook up to this web page with that online Python environment to get live data on the latitude, longitude of where the International Space Station is. And it is only a few lines of code. And again, you don't necessarily have to make it, but you just get that inspiration of all this stuff we're doing with variables and concatenating. You get to see a more advanced application, and it's just that inspiration to keep trying. Okay, then we get into adding random to your programs. So we make a heads or tails, and then we make a dice roll. Now, I actually just want to play the first few minutes of the heads or tails, because I just want to show you that we've got visual props to make it a bit more, make this a bit more realistic.
The heads or tails program is going to use two variables. The first variable is going to store the user input. That's going to be stored in a variable called answer. The second variable is the computer picking heads or tails, and that's going to be stored in a variable called computer pick.
Realise I've probably got to put that into mode, don't I, Martin?
That's all right. It sort of worked. Worked out from my end. It worked.
Sorry. You can sort of see the screen?
Yeah. No, worked out.
Well, I'll just skip through it. But basically, what we're seeing here is that we've got props to show the variables, and then inside the props, we've got the values inside those variables, and then the code skips through.
Yeah.
So I just wanted to add that element of a visual aspect to it. Then we've got dice roll challenge, and I actually start this one with, see if you can do it. Now that you know a few things, can you make a program that outputs a random number from 1 to 6, and a second one that outputs 1 to 6, and then add them together? So then you've got a few minutes, you pause the video, see if you can make it. Do it in Scratch, then Python and JavaScript, and then the video steps you through. And then,
so
of course, we've got...
In all these applications, I think it's important to say to the students that before they actually program anything, that they do might be a flow chart, or might be their pseudocode, where they go through and they do the computational thinking behind it. So if it is a dice roll, they're really thinking about what's going to happen and how I'm going to put it together in a programming sense. And we step through in the lessons, we step through some of those, that thinking. So it's worthwhile looking through those lessons.
Absolutely. Okay, so we've covered the first few concepts of concatenation and formulas. We've got some branching, we've got some randomization. And then the big challenge next is, can you do it? Paper, scissors, rock. So here's a new complexity, because you've got scissors, paper, rock, and as you know when you play the game, it's not just one beats the other. So you've got this myriad of possibilities.
Sorry about that.
It's over here.
Oh,
sorry guys, we're just
charging laptop.
I just saw the charge was down to 0. And can you feed the dog?
Oh, I'm just going to...
Yep. All right. Okay, so how do we solve this problem? And so this one is about, okay, what are the winning possibilities? When you've got the computers picking 3 choices and you're picking 3 choices, there's scenarios where you win and where you lose. So rather than mapping out every possibility, you just say, okay, I only win if I've got paper and the computer's got rock. Those 3 possibilities that come from that. And so when you map out those, the only winning possibilities, it narrows your code down by a lot. Okay, and then the last one we've got here It's password generator. So we've been working with variables and concatenation and randomization. So now we've got a new program that's bigger. So this needs, a variable is not enough, because how this works is it's got 10 words it wants to choose a random one. And it's got that 3 times. So rather than having 30 variables, what we do is we have a thing called an array that can hold multiple items. So it's like a really big one of these that can hold 10 items. And then we use our random skills from before to pick one from each. And then we concatenate and we output as we've been doing. And the props I use for that one is a medication container. And that's just a really neat way of putting a visual aspect to it. And you've got that random choice, and it's quite a neat little challenge. So that's the 5 applications.
Just going back to that array, I really found the video did on that really useful. And even if you've done Scratch before and you use that list, it's really handy to go through that as a teacher, but also with your students to work through that process and use those arrays. So, you know, if you go through the lessons we've got, the students really will build up those basic skills. And I know we're just going through very quickly tonight what's there, and hopefully you can sort of put together what we're saying with what's in the lessons and go through some of the videos. If I can really point you to that variables video to have a look at, so I think Jason really explains that really well. And, you know, just gets a sense, you might use that with your students, you know, to explain variables and so on. So I think there's plenty of resources to have a look at and just to get your head around how you might use that in the classroom.
Yep. So then after those 5 lessons, we've got a few more advanced ones. So the next one is a decision maker. And your choice is, do I make this with variables or do I use arrays? And this decision maker is just simply yes, no, or maybe. And so then once you can do that, it randomly picks yes, no, or maybe, but you make it in such a way that it feels like it's answering your question. So I'll just show you the Scratch version of that. So enter my question. You know, should I have a bowl of ice cream? It says no. So it's made a healthy choice for me. Once you get those 3 working, well, then the challenge is to do that magic 8-ball, which is the classic old premonition toy. And it's got 20 choices instead of 3. And it'll be something like 5 are positive, 5 are negative, and 10 are fairly neutral. And so you have to take those skills of, you know, what worked in 3 when you've got to expand it out to 20. And there's a few hurdles with doing that. And then we get into loops. Now, loops are really what makes programs. You know, loops can just go through massive amounts of data in seconds. So everything has been sort of quite manual so far, but when you add loops into your programs, your programming skills take off. Now I want to show you a times table generator here. And what I think is particularly impressive about this one is that it's only got 3 lines of code. You can see there, 3 lines of code. And if we have a look at the output, what it does is it says, enter a number from 0 to 12. So if I put in 4, and in a second, it generates the times tables for 4. If I run it again and I put in 8, it generates the times tables for number 8. And with only a tiny little bit of code, but if we did this one first, without that foundation of what happens to your variables and how do we concatenate, this program wouldn't make sense. So that's why it's sort of structured the way it is. And this program, when we go into the next phase of making a graphical user interface for it, we make this, it's got a dark green blackboard, white chalk for the text, and a brown border, so it looks like a chalkboard on a school. And again, that only takes a few lines of code to do that. So I quite like that one. And then after the times table, we've got a higher or lower is a classic one. Pick a number from 1 to 20, and whatever you pick, the computer feeds back to you, go higher or lower than that number, unless you've got it. And it goes through step by step. You know, if your answer equals the computer's answer, well, then it says, congratulations, you've got it. Otherwise, if it's higher, tell the user to go lower, and vice versa. So you can make that from 1 to 10 or 1 to 20, or even between 1 to 1,000, as big as you like. And the last program here is a vowel replacer. So I'll show you this in JavaScript. So if I type in water cooler and hit OK, it replaces all of the vowels with similar looking numbers. So this is what the children called leaked. And basically what this program does, the word that you enter, it pulls it apart one letter at a time, runs it through a filter and says, is this letter a vowel? Is it an A, E, I, O, or U? If not, then pass through the filter. But if it is, well, then you change it. If it's an A, make it a 4, and so on. And so it does all of that using those loops from before. It's a slightly longer program than previous, but it's not too bad. And it's really quite a cool outcome. And so then, as we alluded to at the start, is we make all these programs with just text. We make it in Scratch, make it in Python, make it in JavaScript. By the time you work through all of these, you've got all those foundations worked out, and you'll probably start to get some ideas for your own programs. Well, then the next series is going to be, let's make some graphical user interfaces. So I'm going to do them in JavaScript first. So we make all of those programs with a JavaScript interface. Then we make a Python using that tkinter Python interface. So by the time you learn that, you've learnt I can make a little window, I can make an entry box, I can make buttons. When I click on the button, I trigger an event. And so then really the next step is importing data into your program. Once you've got those tools under your belt, your programming skills really come a long way. So that's probably my overview, Martin, on where we're up to.
Yeah, I'm just wondering if there's any questions that people have got while we're able. There's a chat window you can use, or the questions to go through if you want to have a look. Maybe some people have been going ahead and looking at some of the resources we've got. I'd be interested to see if people have got an idea about how they might use some of the videos. The other thing is, I suppose, whether they stick to one language, whether they are more comfortable with Python, or whether they try JavaScript, or whether different students use different programming languages. The other thing is, you might have students who are not so capable with using text-based languages, even if you're in year 7 and 8, and they might use the Scratch programming. At least they're doing the computational thinking, but they may not be meeting the general purpose programming side of things. So we'll have a look. I think we might have a question from Roger, was it? Is there a link for the vowel replacer? So that's coming up. We've got, I think, 5 lessons at the moment. The vowel replacer is, was that lesson 8, Jason?
Yeah.
Yeah, so that'll be our last lesson. We'll probably get that up in about 3 weeks' time. So, you know, by the time you actually go through some of that earlier foundation stuff, that should be ready. We're getting them up as quick as possible. Hopefully got some more questions. I know Rebecca had a question about Python and what sort of year level. You were probably, it's more focused at up year 7 and 8 and up. There might be some students at year 6 who are quite competent at programming, and you know, these videos could be used for those students who are more competent in terms of general purpose programming, but you wouldn't expect primary school students to do that. It's not part of the curriculum. but you might have some students who are able to do that, certainly.
There's just one more point I wanted to add, Martin. In the curriculum, there's a point about separating data from presentation.
Yeah.
And so the idea of that, particularly if you've got a big web page and you don't want to have to make the whole web page again, by keeping the data separate to the presentation, you can change the presentation. And that's essentially the approach we're taking here, is that we're working with text first, and then we're making our graphical user interfaces. And you can change your graphical user interface without interfering on the functionality of your program. And that is a big part of the curriculum, is that separation. So that's another skill that's thrown in there.
Yeah, yeah. So as I mentioned, we've got 5 lessons up at the moment, and they are very flexible in terms of how you want to approach it. We have got that sort of notion where you are learning something, through the tutorial, and then trying to build on that understanding and then modify the program and bring in some of those challenges. I was wondering, Jason, do you have the sugar example that you showed me?
Yeah.
So while I'm just chatting away, you can bring that up, because I think that for me that really sort of got me excited in terms of what's possible. Basically, when we started talking about the project, to get more of the visuals up and running, we understand that students have to go through some of the basics, but I think to see what's possible, what students can do with some of the interfaces, it was quite interesting. So Jason's going to bring up, it's called How Much Sugar, and this really just looks through, if you've got different sorts of, well, there it is there, different sorts of drinks.
How this one came about was that there's a government fact sheet about how much sugar is in what drinks. And like most government fact sheets, it's pretty dry. So I thought, well, why don't we make this into something a bit more visual and exciting? So instead of having this, we can have a little mouse over. So we've got, over here you can see it says water has no sugar. But then if we look at fruit juice, well, we can see straight away it's got 6 teaspoons of sugar. Flavored fruit drinks have this much. The one that really surprised me actually when researching this was a large Slurpee has 21 teaspoons of sugar in it. So I used to have a lot of them, and I hardly have any now because I think about that. And 1 litre or 1.25 of soft drink has 33 teaspoons of sugar. And so this is... Oh, sorry?
I was going to say you're probably going to say the same thing, but it's a great way to integrate, data, use of data, representation, and presenting data. We're doing programming, so we're programming this together, making it interactive. And there's elements here we could sort of talk about in terms of design, in terms of bottle size and the amounts of drink, and just how it tells a story. So there's lots of great learning to go into that. But if you tried to do that from the start with your students without the basics, it'd be pretty well impossible, wouldn't it, Jason?
Yeah, I would call that impossible.
Yeah.
It is quite a jump up, but if you do it sequentially, it will make sense. So another one that I could show you is the dice roll. So the program we had before where we get dice 1 has a value, dice 2 has a value, and add them together. So this is essentially the same thing, except now you've got images, and then you put images instead of your variables, and then you've got the total there. So once you make this one, well, then you start to go, okay, I can make more programs, and then that's how you end up making a program such as that.
Yeah.
The binary one is good. So when you're teaching binary, so you could say, I want to make 97. So you click there and there, and you go, okay, 97. And then you can explain how binary is 64 bits of data, and then one starts here and so forth. But it's just another way to expand your programming skills, but just add a bit more interest into the topic that you're teaching.
All right, well, yep.
I just wondered if I could show one more.
Yep.
So this one was made for the Commonwealth Games, but you can make an application here you could do like the periodic table of elements. So all the answers are presented to you to start with. And then when you run a game, it's either one or the other. And the idea of this one is that it just builds up a flag, and it's got some variables in there that tell you when the game's over. And the idea, though, is that when you come back to the start, I'll just get a few incorrect here. So if it was a table of elements, you would have that table of elements here, and you could make it that it just does the first few. When they get that correct, then it expands. So again, just planting seeds on some possible applications that can be made down the track.
Yep. So I think that gives people a pretty good understanding about what we're trying to do in terms of providing some resources that you can use with your students for programming. Hopefully they're of use, and you can use them with your students. And as we get the new versions up of the remaining lessons, we'll also then be putting together some of these lessons with the graphical interface, which is obviously a bit more complicated. So there'll be some video tutorials to go with that. So I don't think we've got any more questions at the moment. So thanks, Jason, for all your work on this programming resources. I know you spent hours on the videos, and hopefully your dog didn't star too much in the videos you made at home. But thanks all for all your work. And if people have got some questions, or they're using the resources and want to provide some feedback, they can email the Digital Technologies Hub and I'll answer it, or if I can't answer it, I'll send them on to Jason to answer. But certainly we'd love your feedback, and if there was things we could add in if you wanted to, or if you want some clarification on anything, we can sort of work with you on that. So Jason, thanks again, and we might wind it up there, and we'll see people on our next webinar. So thanks a lot, Jason.
Right. Okay, thanks, Martin. Thank you.
No worries. Okay, see you. Bye.
Bye. Ethan? Can you feed her, please? Huh? Yep. It was a it was a bit chaotic. No. Probably shouldn't have tried it at home.